You know, there's a silent coup happening right now, right at the heart of our digital world. A dynasty that's lasted 50 years is being overthrown, and believe me, it's changing everything from our data centers to global politics.
And look, this isn't some sci-fi prediction about the distant future. No, our source material makes it clear. This is the reality today in 2026. The shift isn't coming, it's already happened. The king has fallen.
All right, let's really get into this. For, half a century, the CPU has been the brain of every computer out there. But that's over. It's been dethroned by a totally new kind of processor, one built specifically for AI. And here's the kicker. If you're still building data centers the old way, packed with CPUs, well, that's not just outdated, it's now seen as a catastrophic financial mistake. So, you gotta wonder, why did this happen so fast? The answer is actually pretty simple. The CPU, as brilliant as it is it's the wrong tool for the job. Its whole design, its entire philosophy, is completely at odds with what AI really needs to thrive.
Okay, here's a great way to think about it. Imagine a CPU is like this brilliant genius professor, right? It can solve these incredibly tough, complex problems, but only one at a time in a neat little line. An AI, it doesn't need a professor. It needs an entire army of laborers. And that's the GPU. It's designed to do millions, literally millions, of super simple calculations, all at the exact same instant. And this is where it gets really wild. The numbers totally back up that analogy. Look at this. If you want to run an AI like Llama 3, right? A whole cluster of 16 high-end server CPUs, well, it can spit out about 45 tokens a second, okay? But a single new NVIDIA GPU, it's cranking out over 28,000. And it's doing it with way less power, which makes the cost just plummet, from over $12 to 2 cents. I mean, that's not just a little better, it's 1,000 times better kind of leap. But wait, there's another fatal flaw for the CPU when it comes to AI. It all comes down to physical distance. It's something called the von Neumann bottleneck. Basically, the processor spends most of its time and energy just sitting there, waiting for data to make this long, slow commute from the memory sticks all the way across the motherboard. When you're dealing with these gigantic AI models, that commute actually costs more than the thinking itself. It's crazy. So how did GPUs solve this? It's brilliant. Instead of having the memory way over there, they stack it three-dimensionally, right on top of the processor. And this move gives them insane memory speeds. We're talking up to 8 terabytes per second. To put that in perspective, it makes a regular computer motherboard look like it's stuck in traffic. The bottleneck? Poof, it's just gone.
Okay, so this shift isn't just a technical detail. It's creating a whole new world order. With the CPU basically demoted, two companies have really stepped up to build this new silicon empire. You know who they are, NVIDIA and AMD. And they're both coming at it with completely different strategies. NVIDIA's strategy? Well, they basically decided to fire the final shot in this war. They created what's called the Grace Blackwell superchip. They literally glue a small, efficient ARM CPU right onto their massive GPU. So what's the CPU's new job? It's just a middle manager. Its only role is to run around, grab data, and feed it to the real boss, the GPU, as fast as it possibly can. What a demotion, right?
AMD, on the other hand, they took a different route. They looked at the single biggest headache for AI developers, memory capacity. So they built the MI400 accelerator, and it is a juggernaut of memory. We're talking a massive 288 gigabytes of super-fast VRAM on one chip. Why does that matter? It means a customer can run a huge 100 billion parameter AI model on just one piece of hardware. That's an incredibly simple and attractive pitch.
But all this mind-blowing power comes with a serious price tag. We are slamming headfirst into the unbending laws of physics. All that energy, all that computation, it has to go somewhere. And where does it go? It becomes a terrifying amount of heat. Just look at this jump. A traditional server rack, it pulled maybe 15 kilowatts. You could cool that with regular old air conditioning, no problem. A modern AI rack, we're talking up to 120 kilowatts. As our source material puts it so well, trying to cool that with air is like blowing out a jet engine with a desk fan. It's just physically impossible. Air isn't dense enough to carry all that heat away. And this is the new reality. If you walk into a cutting-edge data center today, you might be surprised. It looks less like a computer room and more like some kind of industrial plumbing facility. Seriously, you've got pipes everywhere, pumping liquid coolant directly onto the chips, soaking up that intense heat instantly and whisking it away.
And believe it or not, it gets even more extreme than that. For the absolute most powerful systems, companies are literally submerging entire server racks in these giant vats of special, non-conductive oil. Just dunking the whole thing. I mean, that's the level we're at now.
So think about this. A fundamental change in a tiny little piece of silicon is now sending massive shockwaves across the entire globe. It's reshaping everything from water rights to international sanctions.
And this brings us to a real paradox. You've got nations in the Middle East spending hundreds of billions of dollars to become global AI hubs. But to run these massive computers in the middle of the desert, you have to evaporate millions of gallons of water every single day, just for cooling. Suddenly, being a leader in AI is directly tied to water security and having enough nuclear power to desalinate all that seawater.
And that, right there, creates a powerful new geopolitical weapon. Access to these chips is access to power, plain and simple. So what do? What happens if your country gets hit with a silicon embargo and you're cut off from buying the latest and greatest AI hardware?
Well, you get creative. Engineers are finding ways around sanctions by building something called hyperclusters. It's pretty clever. They take thousands of consumer-grade gaming graphics cards, the kind you'd buy for your PC, and they link them all together, often using old crypto mining farms. The goal? To create a massive, decentralized supercomputer. And the result is, it makes enforcing these kinds of sanctions nearly impossible.
Okay, so here's the crucial point. Even with all this wild, exotic liquid cooling, we are hitting a hard wall. The absolute physical limits of what silicon and electricity can do. The next big leap, it can't come from electrons. It needs a whole new medium. We have to stop moving electrons and start moving light.
The name for this is photonic compute, and the idea is revolutionary. Instead of pushing electrical signals through tiny copper wires inside a chip, you send pulses of light through microscopic fiber optic channels. And since light has zero electrical resistance, moving data this way generates zero waste heat. It's a total game changer for efficiency.
Right now, the most advanced systems are actually hybrids. They still use good old silicon transistors to do the number crunching, the math. But all the communication, all the data moving between different parts of the chip, that's all done with lasers. And this lets you stitch together tens of thousands of individual processors so they all act like one single colossal brain.
It's like history repeating itself, really. Remember how fiber optics made old copper telephone lines obsolete? Well, now photonics are doing the same thing to the copper inside the chip. As the source material puts it so perfectly, the future of compute is quite literally made of light.
So let's just quickly recap this whole incredible shift. First, the CPU's 50-year reign, it's over. It's now support chip, not the star. Why? Because AI needs massive parallelism. But that comes at a cost, an energy crisis that's forced us into industrial-scale liquid cooling. And that, in turn, has tied AI leadership directly to geopolitics, water, and energy. And finally, the next great revolution is computing with light.
And that really leaves us with one final fascinating thought. We've just seen how a tiny change in silicon manufacturing leads directly to a need for nuclear power desalination plants. It just makes you wonder, if the very future of intelligence is being built on this bizarre new foundation of industrial plumbing and the speed of light, what other, seemingly unrelated part of our world is about to be completely transformed by it next?